Hello. Good morning, Stavanger. It's lovely to be here. I'm going to be talking about building MCP with .NET, but crucially, building it in a safe and reliable way. Because I'm pretty sure if I turned to anybody in my security team and said, by the way, we're going to expose all of our data in an unprotected fashion to an LLM, they would lose their minds. So we're going to, try and de-hype this a little bit, look at doing this safely with .NET. As I mentioned, I'm Callum. I'm a Microsoft MVP for 5 years now. I'm a .NET developer. I run a consultancy called Bump. I speak all over the world. I actually live in Sydney now, so I've possibly traveled the furthest of anyone to be here today, but it's lovely to be here. And I'm on socials that handle basically everywhere. So let's dive in. What is MCP? Well, of course, Jostein has gone before me and explained a lot of this, but we'll give you a little recap just to make sure everyone is up to speed. MCP, according to ChatGPT when I was preparing this talk, is the Minecraft code pack. So, there is a small delay in knowledge here. But no, actually, if you're expecting Minecraft tips, I'm really sorry, I have none. The Model Context Protocol is what we're talking about today. The Model Context Protocol is a JSON RPC-based protocol. So it uses JSON RPC effectively, JSON in, JSON out. And it's become the de facto standard for connecting different AI assistants and systems together. Developed by Anthropic, but one of the good things about the AI world is actually they are trying to share knowledge and they are building on each other's standards. So much like the OpenAI API, spec has effectively become the de facto standard for AI APIs, Anthropic's MCP has now become the de facto standard for agent-based and system-based communication. Google's tried to throw their hand in the mix with A2A, their agent-to-agent protocol, and there's a new one called MSP as well, which is for like stateful stuff, but it doesn't really matter. Today we're talking about MCP, and it's the Model Context Protocol, as I said. Again, a quick recap over some of these key concepts that we'll need to know. So there's three key components to the MCP journey. They are the client, which is what is connecting to a host, connecting a host to an AI system that is running with MCP servers, backed by large language models typically. And the beauty of this is you can kind of plug and play all the different parts. So you bring your own server, you bring your own preferred client, and you bring your own LLM, and they all have different quirks and properties. So you find the one that works best for you, and you use that. The MCP server is what effectively is doing all the hard work. That is connecting to your client, interfacing with your large language model, and making sure that it provides capabilities to the client for consumption. And these capabilities are effectively what means your MCP server can do things. The capabilities are things like tools, prompts, resources, and elicitation. These are the key things that a server might provide. Today, we're only really going to focus on tools because you can go quite deep into all of these different things. And if you've seen the previous talk, you'll see conceptually they're quite similar. They return different types of data. So a tool is effectively designed to execute some code on a server. It leverages functionality that exists in a lot of large language models called function calling. And it's designed to execute code effectively, pass in parameters, etc. Prompts are like pre-saved prompts that you might be able to refer to by name and call upon to perform certain tasks. Resources are a way of pointing your large language model to file system paths or APIs. And elicitation is a way of the server and the client having some kind of conversation, some engagement to elicit more information. But yeah, we're going to look just at tools today and how you might actually go about implementing this in .NET. If you look at the life cycle of a MCP connection, you effectively have your client sitting in the middle, and the client is there talking to your model of choice, living somewhere in the cloud probably, and connecting to multiple MCP servers over either JSON RPC or HTTP. You can actually connect to them over HTTP as well. And if you're doing that, they effectively act just like any other REST API that you'd be used to, but they're speaking the same schema and language. This is stripped straight off the Anthropic MCP documentation, but I think it gives a really good idea of how the actual, exactly what's going on when you make a call to an MCP server. So you have your discovery phase. The discovery phase runs by your client to understand, of all of the MCP servers it has a connection to, what tools are available if you're looking at tools. This will also apply for resources and prompts and other features that your MCP server supports. It calls off to the tools list endpoint, which returns a list of tools. From that, you'll give your client some prompts, and it will work with the large language model to reason over the list of tools and the descriptions that have been given for them to determine which one should be executed, or which tools, could be multiple, should be executed to perform the task that's been requested. And then finally, it will invoke those tools, calling the tools/call endpoint, return the result back to your client, and the LLM will formulate a nice, friendly response rather than just spitting out JSON data to you. So you can kind of get an understanding for how this whole system hangs together. Under the hood, this is the kind of JSON type things that are going on. So the tools list endpoint, as I mentioned, returns a list of tools. You'll notice they've got some quite specific properties. So a friendly name, like in my case, speaker profiles. I've created an MCP server for HelloStavanger to get information about key speakers and where rooms are, etc. You give it a function name, in this case, get_speaker. The reason for that syntax, get underscore, is because LLMs are really good at Python and less good at other languages, and Python loves to use this naming convention. So if you want better, more reliable matching, give your tools names like that. A description, a semantic description. Now, this is really where all of the value in your creating of your tool goes, giving a really good detailed description of the things that it can do. You don't need to go to great lengths and list out everything, especially not every possible combination of things you could pass into it. But this is the value that the large language model is going to use to determine whether this tool should be called. So the better, more accurate description you can give, the more reliably your tool is going to be chosen by the large language model. And finally, some input schema. If you wish to have parameters that get passed in, this is how you would do it. You can mark them as required or not. Once that tool's been selected, it will get called and invoked by the client by calling off to tools/call, this endpoint with the name of the tool and any arguments that are required, and we'll return a response, this result object, which includes some content, and there's a few different content types you can return, but in this case, we've just got a text example. So you could see there how all of these different calls tie together. Of course, no one really wants to be writing code that interfaces with this raw JSON data directly, so we use the SDKs that are available. And as Jostein mentioned, there is a ton of SDKs available from a variety of different languages, so you don't have to write your own. MCP servers have kind of taken the world by storm in recent months. Basically, every product team, I think, has been scrambling to get an MCP server available. There's a bunch of them for GitHub and different Microsoft products. GitHub one's one of my favorites because you can ask it questions about, what's in my GitHub orgs that I have access to, or what's in this repo's code, and it can understand and infer things and give you quite a lot of good insight. So do I have any dependencies that need updating? Well, the GitHub MCP can tell you that. That's pretty sweet. Playwright is a headless, I'm not sure how you describe it, testing framework, I guess, front-end testing framework. But now they have an MCP server, and it means that you can do, it opens this new age of testing. I think it's being coined semantic testing, where you can give it human language instructions, and it will go off and it will create those tests and execute them for you. So if it's a case of, hey, I need to just validate that my front end hasn't broken anything, I've made some upgrades and I want to make sure it's visually the exact same as it was before and after, it can run those tests for you and you don't have to write a single line of code now. That's just mind-blowing to me. And Puppeteer as well, again, headless browser, but for doing things like navigating the web. Hey, go check that my form is working. Go submit this form for me on my behalf. And you can let MCP just handle all of that. So we're going to look at building an MCP client in .NET. But as I said earlier, doing it safely. We'll talk about some of the key security concerns along the way, and also just ways to make the developer experience a bit nicer when working with MCP and .NET. There's some very basic implementation that we can do out of the box, and then there's some ways we can go a bit further to make that more powerful, more friendly, and integrate better with our existing applications, should you have them. So there's probably two key libraries we're going to talk about today. The .NET Model Context Protocol SDK, that lives in a community GitHub organization. It started actually its life in the community. This was built by a member of the .NET community. It was then forked and brought into the MCP org, which is a collective of different organizations and maintainers all over the world helping to maintain these things, but it's all open source. And then on the other side of this is Microsoft has this very popular library called Semantic Kernel. And Semantic Kernel gives us a nice wrapper around various ways of interacting with LLMs through .NET. Gives you a whole bunch of features that just make that developer experience really nice. Now, about 2 weeks ago, Microsoft announced that they're killing this product. Not quite. They're rebranding it, reformatting it into a new thing called AI extensions, and it's going to become they've already got another AI platform that does something quite similar that's very agent focused called Agent Gen, I think. And yeah, they're merging them into one. But the concepts remain the same. They've got plugins and functions and things that very much exist. Now, these semantic kernel existed way before MCP, but we're going to look actually at how you can use the two side by side to benefit from all of that nice developer experience stuff Microsoft's done, and also still conform to the MCP protocol. So that's quite cool. Now, I'm going to go to a bunch of live demos because I'm feeling brave this morning. Hopefully you are too. Let's see if this works. The beauty of AI demos is sometimes they just go wrong because today the LLM has decided to do something different, or it's using a different model in the background if you're using GitHub Copilot, for example. So yeah, we will see. For those at the back, can we vaguely see this well enough? Is that okay? I can zoom in a bit more? Yeah? All good? Fantastic. So here I am in VS Code. In fact, it's a GitHub code space running in my browser. And I've created a .NET application as a sample project where I'm going to implement an MCP server. If we look over here, I've created, we can ignore these couple of folders, but I've created a client, a C# class library called MCP server. And inside that, I have installed one plugin only called Model Context Protocol. It's a preview package right now. They have still yet to release a stable version, but it's pretty stable. You could be using this in production if you wanted to. This is effectively just a standard .NET class library. It's doing nothing special at all. In fact, it's a web application, this one, for a later demo. Per the standard .NET process, .NET applications have an application builder. Our program.cs class is responsible for constructing our application. And typically, this would do create a host builder, and it would call builder build, and then run the application. To register our MCP server, when we install the MCP SDK, we get a couple of extra extension methods that we can call that allow us to register all the things needed for an MCP server in .NET. So by simply calling builder services add MCP server, that now bootstraps all of the different stuff behind the scenes to make an MCP server work in .NET. After that, we need to choose a couple of things and decide to register some tools and some behaviors so that our server can actually do things. In this case, we need to decide which kind of protocol, which kind of transport we actually want to use. Because I'm just building an MCP server for myself that's going to run locally, I'm very happy using the JSON RPC-based setup, and I'm therefore going to use the standard I/O server approach. This is the default that MCP servers expect. And finally, I need to register some tools. Well, you can do that manually by saying .add tool, I think. But there is a helpful extension method called tools from assembly, and it will go and scan your assembly for certain classes with certain attributes and patterns to make this a lot easier and cleaner to register. If we jump over here, I have a tools folder, and I've created a couple of very basic tools that allow me to give my MCP server some capabilities. The first one is a conference tool. It's a static C# class with a static dictionary inside of a list of upcoming Norwegian conferences and also their dates. I've then created a few tools to get a random conference, very basic, and another one that gets the date of an upcoming conference by its name. Hopefully this is like minimal code and you can kind of understand what's going on. The detail of what's going on inside each function doesn't really matter. For the purpose of the MCP demo, what you need to know is there is an attribute that is decorating this class to say this is an MCP server tool class, and then each of these functions that I want to run, I want each of these functions to become an MCP tool themselves. I decorate it with my MCP server tool attribute and a description. This is our semantic description that tells the LLM how it's going to bind to this function, when it should call this and why. That's kind of it. All of this is provided by the by the MCP SDK. The only crucial thing you need to know about this is it has to be a static class in order to work. The MCP SDK is not able to instantiate classes with dependencies and stuff right now, which is a shame. I'm sure it'll come, but for now, this has to be a static class. These get scanned, as I mentioned, by the code here that's in our with tools from assembly, and that's kind of it. We've got a server. So let's see how we would go about using this, because it's still all very conceptual right now. VS Code and basically every IDE under the sun now ships an MCP client. So you're able to use that to connect to various MCP servers. And in VS Code, we can do that. They come through extensions. So inside here, you'll see I have a list of MCP servers that I've got installed. I have created my .NET MCP in configuration. I'll just show you what the configuration actually looks like. So every single MCP server can be configured through this mcp.json file. This is an adopted convention that most clients are going to follow. And in here, you can list all of your different MCP servers that you need. The beauty of this is, if you want to ship those by default in your project or in your dev container image, you can do that. You just drop a mcp.json file in. In my case, I've created my .NET MCP server at the top, and I've given it a type. The type is just to tell MCP how you should be interacting with this server. It's a standard I/O type in this case, and because my app is .NET, I've told it, actually, I want you to execute a command every time I ask you to invoke this MCP server. So the host is going to go and boot up that MCP server every time I need to ask it a question. It's going to run my .NET project. Now, if we jump over to here, in VS Code, I can click Start Server, and you'll see the terminal starts whirring away over here, and it's going to build my application, and it's discovered that there are 5 tools available, the 5 tools that I've registered in my static classes. If we take a look here, we've got our conference tool, and we've got our speaker tool as well that just returns some speaker bios and stuff. That's quite cool, so let's see how we can call this. As I said, VS Code ships with GitHub Copilot and has the ability to interact with these MCP servers directly. If you're using GitHub Copilot and you're using agent mode only, you can ask questions to any MCP server that is running and accessible to you. In Visual Studio and Rider, they have a similar concept. You need to be using the agent mode. You can use Claude Code as well, also in agent mode, and I think fairly recently it was announced in the OpenAI ChatGPT dev mode as well that you can do the same thing. So they all support, all these popular places that you want to be able to call your MCP server already supports it. If we just look here, we'll see that it's picked up that I have a couple of different MCP servers available. These are things that have been added by VS Code extensions, things I have installed, and my own one as well down here, my .NET MCP server. Just for the sake of this demo, I have turned off the other ones, and let's click OK. So I want to ask it a question, and only something really that my MCP server itself would be able to answer. So yeah, let's look at this. Let's ask it to name a random conference, shall we? Name a random conference. And let's hope that it's going to choose HelloStavanger, because of course, what? Sure, I don't care. I think it's because I have auto mode selected down here. Right, fine. So it's going to ask me if I'm happy to execute my random conference tool from the MCP server. As Justine mentioned, you need to be, well, best practice is to have human in the loop here and make sure that the human is aware of exactly what is going to happen every time they do. I'm going to do something very naughty and just tell it to always allow it for the purpose of these demos. So NDC Oslo. Okay, fine. It's come up with a random conference from my list. Let's ask it to do it again and just see if it will. Yeah, fine. We'll see if it will do the same thing. So it's again selected my yay woo. It's selected my random conference MCP tool and it said, "Yep, I'm going to return you an event, HelloStavanger." I can now ask it follow-up questions that will, through the LLM's inference, decide I'm going to call other tools that are available. So, for example, I have a tool that says get the date of a conference, and I can ask when is it, and it should tell. Yeah, fine. I might have to switch to a GPT or something. So it's going to ask me, do you want me to run the upcoming conference tool. It's determined that it takes a parameter, a name, and it's determined that it should pass HelloStavanger in, and I'm just going to say, yep, fine, allow that, and it's going to run, and it's going to say it's today, woohoo! So that's kind of cool, but wouldn't it be great if we could do something maybe slightly more meaningful, and maybe something that actually interacts with real data or does something a bit more transactional, perhaps retaining state. So I have my speaker tool over here, and let's just collapse a couple of things. For the purpose of this demo, again, it's a static class, very basic. I've created a dictionary in my class of speaker ratings. And I want to make sure that I can rate different speakers based on how they perform today. Of course, you can give feedback on these sessions afterwards in the agenda as well. So similar idea, I want to be able to score speakers. I've got a small list of some of the speakers who are presenting today. And I'm able to ask the tool to actually perform a task, and it will mutate that data. Because my server is running in .NET, and because the process is effectively continuous as soon as I start that server up, for the lifetime that that server is running, it can retain state and it can retain information, and I can keep asking questions and doing things here. If you were running this in the cloud, you'd obviously want to be persisting this to a database or something like that. So let's fire up our model again. I've changed to GPT-5 just to see if that's going to help things. So let's rate a speaker. Let's say rate Richard Campbell 5 stars. That keynote was awesome, wasn't it? So let's ask it to rate Richard 5 stars. And it's going to think about it again, and it should say, yep, okay, I've determined that there is a rate speaker tool available. I've determined that there needs to be 2 parameters now, a name and a score, and we're just going to allow that to happen. And it's going to rate Richard. Cool, he's recorded it. Now, we can ask it some slightly more complex prompts, like rate Callum Whyte 5 stars, and rate Richard 5 stars. So this is now performing 2 tasks. It's going to determine that it needs to call that same MCP tool twice, because there is 2 different requests here. Firstly, I asked it to rate myself 5, and then to rate Richard 5. It's going to do each of those tasks, ask me each time, and said, yep, cool, I've updated that now. And then just for the sake of making sure this is fair, I'm going to say rate Callum 4 stars. But the great thing is, this is all storing this state in the background here. And I can now ask it a follow-up question, like, give me the average scores for the speakers. I have a tool down here to get the average scores for each speaker. And this will prove that it's been retaining that state. I've rated myself 5 and 4, so I should have a 4.5 score. And Richard, of course, is a 5-star speaker, so he has got a 5-star score. We'll allow it to run that tool, and yeah, that's not quite what I wanted. Anyway, never mind. Yeah, fine. We'll talk about auth. I wanted to show you something else, but we can do it in the next bit. So authentication is really important, of course. Right now, I've just built a standard, very basic MCP server that's doing, completely safe things on my own data. The chances are, if you were building this application yourself, you would then want to be able to call off to existing service layers you might have in .NET or existing APIs that you might have. And those are going to require authentication and authorization. People need permissions to be able to do things, and if you're building a public server in particular, you don't want just anybody to be able to do anything. So auth is a really important concept. Now, MCP, the protocol, supports OAuth 2.1. That is the standard that it's accepted, which is awesome because it is the bleeding edge of the OAuth spec. In fact, so bleeding edge that .NET doesn't support it. .NET is OAuth 2.0 compliant. 2.1 isn't really even an official spec. It's 2 plus a few extra things that they've deprecated removed. Thankfully, the stuff that they've changed and removed, .NET kind of did anyway, so it's okay. We can still use .NET's OAuth 2.0 support and make it work with MCP. MCP has this concept of a protected resource, or protected resource metadata. So when you register your server, you can say, yep, I require authentication, and you need to use one of these external authentication services. So you provide it with your authorization server, that would be your OAuth server, and it could be using something like auth0 off the shelf, or that could be a path to your own local .NET, ASP.NET identity-based auth server as well, so you get a bit of control there. You can tell it different methods it supports and kind of broadcast here all the different behaviors that my server can do. So the MCP client knows exactly how to behave and interact with it. Let's check out another branch that I've got that I can show you this configured in practice. So terminal. Oh, I need to stop my server first, don't I? Because that will cause many problems later. Git checkout main. Great. So in order to configure authentication and authorization, there's relatively little that we need to do. If we look to our program.cs here, you'll see there's quite a bit more stuff in here because there's a few other demos coming. But essentially, I need to tell my .NET application that yes, I need to use authentication, and these are the different schemes that I'd like you to use by default. So it requires, in order for a request to be made to this, that it's authorized. And then I can, when I register my MCP server, provide that resource metadata. Simply as instantiating an object here, tell it the scopes I support, and point it to different resources and endpoints that I then want to use myself. So I've set up the ASP.NET identity-based auth, and I've added that here, and told it to use these authentication methods, told it it requires authentication, and away it goes. So a few lines of code and you have full, locally hosted authorization working with your MCP server, which is quite powerful. Crucially though, .NET's authorization authentication middleware relies on HTTP, not on RPC. So in this case, I've actually had to switch my MCP server to use HTTP transport instead. But the beauty of this is all of the other .NET middleware, like rate limiting, like authentication, all that stuff continues to work just as it did before. So we can, just use the basic .NET auth stuff that we're used to. But of course, in our individual tools, we might want to do certain things, like saying, hey, this tool specifically can do certain things or is allowed to be called by certain people, and other tools are not. How would we go about doing that? Well, the MCP spec doesn't quite yet support tool level or capability level authentication and permissions. That's kind of the responsibility of the server to implement. The server can, of course, at the point you authenticate, say, hey, this user doesn't have permission to see these tools or execute them, so just don't even return them, don't register them, don't tell the user these things exist. But really, if we're doing this properly, we should be putting some kind of authorization layer inside our tools. Now, it's a bit painful to have to do that manually each and every time. So this is where Microsoft's Semantic Kernel really comes into play. I'm going to just jump to another branch. No, I'm not. Screw it. We'll stay on this branch. Maybe it won't work, though. So, Semantic Kernel is Microsoft's SDK for integrating with .NET and LLMs. And the beauty of it is they have these concepts of plugins, which are very similar to tools. They are code that can be executed by a large language model. And we're able to tell MCP that we want it to use any semantic kernel tool, plugins that have been created to also be registered as MCP tools. The anatomy of these is very similar. I have a class. I have an attribute that I decorate each of my methods with to say this is a kernel function, effectively an MCP tool, and I give it a semantic description. Beyond that, this is the same thing. The beauty of this compared to, say, the MCP SDK is these all live in the dependency injection container. So I can inject any of my dependencies that I want into here, be it a service layer or some other kind of internal library that we're using. I don't have to use their static class approach. So this is quite clean. But the other thing they do is have a thing called filters. And Semantic Kernel will run these filters before the invocation of any plugin and after as well, should you wish. You can register pre and post execution. And that allows us to put our authorization code somewhere centralized and have that logic run whenever one of these plugins gets called. So I've created a filter up here in my auth filter. And you can see this is a auto invocation filter. And it will check to see, hey, does this current request have an authorization context? And if it does, check if the user is in the role that has been defined on the attribute that I've decorated my function with. So if we jump back to my venue plugin, I've misused and abused the .NET authorization attribute to be able to decorate my tools and say, these tools are only available when one of these roles is true. And then my filter actually executes when the plugin executes and says, yep, sure, you do or you don't match that role, and you can proceed. So it's kind of this halfway house where I'm slightly rolling my own authentication mechanism there, but leveraging as much of what .NET offers. .NET will already have assigned the roles to the user at the point they've authenticated. They're managing the auth. I'm not actually touching that. I'm just purely managing whether it's allowed to proceed or not. And in my filter, I think I just throw an exception or bomb out if it's, I return a different type of result, not allowed to do this thing. So that's a nice, quite easy way of leveraging something that Microsoft already has there, and yeah, putting auth in a clean way where you don't have to repeat yourself a whole bunch of times, just authorization attributes. You did see a few extra things in the program CS at boot time. Semantic Kernel has its own builder, so in order to register my my plugin at the start, I have to create a Semantic Kernel builder, add my type manually, and also register my filter. And then beyond that, the only thing needed to tell Semantic Kernel about, to tell MCP about my Semantic Kernel tools is to add with tools and tell it, here's the kernel, just use these. And it maps it all together. So I don't have to write anything specific. That means if you've already got a Semantic Kernel application running somewhere, you can add MCP with literally one line of code. If you don't, but you want filters and some of that more advanced functionality that the MCP SDK, it doesn't have, and it's arguably too opinionated for MCP's SDK itself, then Semantic Kernel's a perfect pair for you as well there. So I think that's quite fun. So I'm going to point you to this blog post. Den Delmarsky, he is one of the guys that works on the MCP SDK for .NET. He is on the .NET team at Microsoft as well, and he's written some amazing blog posts about how you do authorization in MCP, in C# and .NET. So you can go check that out. He's a very knowledgeable guy and has a whole bunch of information in here. Don't worry, this QR code's coming at the end as well, so you don't need to grab it now. Wait for the cameras to go down. Cool. Sorry. It's coming back later. We've talked about auth, but actually security is quite important. And there's some big concerns if you are deploying an MCP server into production. Thus far, we've only shown you a server sort of running on a local environment. That's potentially quite limited. But there's huge considerations if you're going to deploy this to the cloud or deploy this remotely. As I mentioned earlier, if I told a security team that I was just putting a public API anywhere that anybody could call without authorization and it can do anything and access all of our data, they would lose their heads. So there's some key considerations that need to be made if you're going to deploy this. There's also three fairly common threats that AI systems, intelligent systems, face when running publicly, and you have to be quite aware of these. The first is unauthorized execution. Are my tools or my resources in my MCP server being called in an unauthorized way? Be that someone that shouldn't be calling these tools in the first place, they're not authenticated, or be this someone using those tools in a malicious way, trying to inject data into my system. Things like SQL injection are things that we care about a lot when we're building web applications and APIs. This is no exception. You should be validating any data input, you should be filtering and making sure that it's safe. Before you go writing things to a database or calling off to an external system. Another one, a key attack vector for AI-based systems is prompt injection. Every MCP client, effectively every application that's working with an LLM has a base prompt, and that prompt tells the LLM how it should behave and how it's going to work and how you're going to interact with it. People have to varying levels of success, manage to manipulate those base prompts, tell it to forget everything and actually I want you to do this other thing instead, or manage to tell it when I do this certain thing, you should do something else instead. There's all kinds of very sophisticated attacks going on here, people even going as far as like injecting Unicode characters in there, and yeah, it's all a bit fun. But prompt injection's a big consideration. And finally, tool poisoning, especially when we're talking about MCP, is a really big risk. This is the idea of replacing trusted tools with malicious ones, something that you have gone and installed and said, yep, I'm happy to call this tool, but being replaced by something that is not the tool you're thinking of, something with the same name. Jostein mentioned like human in the loop. Human in the loop here is exactly why this thing exists. They're getting you to make sure that you're checking the tool that is going to be executed and the data and the prompts that are going to be executed is exactly what you're expecting to happen, both from a security and a sort of general safety perspective. I might sound like I'm, tinfoil hat and whatever here and trying to scare you, but this is very true. This is a big risk. Those descriptions against each of your tools. If someone wants to come along and register a tool with the exact same name or a very similar name, but a better description that's going to match better to the kinds of requests you're making, the LLM will reason and decide they're going to choose that one instead. You have very little control over which tools the LLM actually decides to use. So you as an implementer have a big responsibility of making sure those descriptions are as clear, detailed, accurate as possible for making sure that the right tools are executed. Another tip that I give you here is if we're in our client, for example, and I go down to the configuration, you can opt in to certain tools. And this would be a recommendation you should just do across the board. Don't blindly accept every MCP server and tool that's been registered. VS Code applications are able to register their own MCP servers for you. And VS Code applications also auto-update. There's, in fact, yesterday, a new supply chain attack going on for VS Code extensions, where they'll auto-update, install some kind of malware, and it will run in the background on your machine, scanning for secrets and stuff. Those extensions could be compromised. They could auto-update, add an MCP server that registers a tool that is exactly the same as another popular one that you're using, and just because you've blindly accepted everything, it will consume that and be like, yep, we're going to use that, farm requests off to another tool, a malicious third party, etc. So you can opt into specific tools rather than opting out of stuff, and I'd recommend you do that as a kind of best practice. So the other consideration, if we're going to put this into the cloud, is scaling. Like, right now I've showed you one person connecting to one instance, and that is great, but that doesn't really scale. So you can build multi-tenanted MCP servers. They don't have to retain state like I have. They can have multiple connections at the same time, and that's all good. The kind of standard scaling practices for any application still apply. You can create more instances of it, or you can create a bigger instance of it. But in the cloud, there might be some better ways of doing this. So Microsoft has created this new .NET Aspire thing, which is very trendy at the moment, and everyone seems to be loving it. And they also have the Azure API Management Service. These are your two best tools, in my opinion, for scaling an MCP server built in .NET right now. .NET Aspire allows you to create a containerized version of your application and deploy that to the cloud, such as on Azure's container apps, with very minimal amounts of code, literally a few lines of code. And the API management gateway is not something you'd be expecting to see when we're talking about AI at all, but actually it's got some huge AI gateway features that you wouldn't be aware of. There are companies that have dedicated AI products, AI gateway products, and I wouldn't be surprised if at some point Microsoft decides to split these two out or distinguish them a bit better. But Azure's API Management Gateway can do a ton of stuff for identifying and securing requests to large language models and intelligence systems behind the scenes. They can already detect things like prompt injection attempts and reject it before it even gets to your server. So this is a really great tool to just stick in front of your application and make sure that it's going to be safe. It will also do things like rate limiting and a whole bunch of other stuff. So I'm going to show you kind of how we might go about doing this in practice, how we might set this up. Let's tell you to go away, and you to go away, and I'm going to swap branches to a branch called Aspire. Lovely, that's cleaner. So we're kind of still got our semantic kernel program CS here. It's the exact same MCP server that we've been used to seeing. The only difference is we've got these two extra projects now. We've got our MCP Aspire app host, and we've got our service defaults. The service defaults is purely some Aspire-specific configuration, and it keeps it centralized. There have been no changes to our MCP server project. Instead, I've gone to my .NET application, I've installed Aspire, and it's created this app host project. Within that, I can then say, I want you to add this project, and that's kind of it. So if I was to go and check this out, MCP Aspire app host, and I .NET run, where before this would have just been my MCP server, this is now creating a isolated instance of that MCP server that I can spin up as many instances of as I want, and that's running directly in the, in .NET in this case. Let's hopefully boot this up. No, it always does that the first time, and then the second time works. I don't know why. There we go, cool. So this is the Aspire dashboard, and as you can see, I have one instance of my application running here. This is my MCP server running directly in the cloud. It's got a host name, a public host name, which is awesome, because if I'm wanting to have other users connect to my MCP server, they can do that. And in VS Code, that works very similar to the way you'd have connected to any MCP server before. I have my Aspire MCP server here. And the configuration is we're going to give it a URL instead and tell it it needs to connect over HTTP this time, not over the JSON RPC protocol. So because I'm running now, I can start my MCP server up, and we should see, hopefully, yep, it's discovered that I've got 7 tools available. That's the original 5 that I created in my MCP plugin, and the additional 2 that I created in Semantic Kernel. So we've got our 7 tools running there. And if we attempt to make another request, oh yeah, I forgot that one failed, didn't it? Let's try this again. I'm going to make sure, firstly, that I'm opted in only to the Aspire MCP server that I've created, and then I'm going to, give it a request like name a random conference. It's going to think about it. It's going to ask me, do I want to execute against my new Aspire MCP server? So choose random conference against Aspire MCP server. Sure, we'll allow that, and we will let it run and get a result back. Not so worried about the result here. The benefit of using Aspire is they have full tracing also baked in. So if we look into here and we look at our trace logs, we can see every time and the details of every single request that has been made by an MCP client to our MCP server. That first one at the 150 milliseconds was going to be getting all of our different tools, and then thereafter is going to be the actual interaction. So in theory, I've got 5 there now, haven't I? If I do another one, I say again, and we come back over here, we should see a 6th one appear. Oh, it's going to prompt me, isn't it? Quick. Yay, cool, shows up. So yeah, you can actually start to bake tracing and telemetry into your MCP server. If you're running it in production, you're going to want to know how it's being used, so you can see if there was a malicious attempt at using your client, your server for whatever reason, you can see the details of exactly that. The other beauty of Aspire is we can create as many instances of this application running as we want, and it containerizes those, and it deploys and manages those container instances. So should I want to deploy this to the cloud and have an instance running for every single user in my organization, I can do that. Or should I need to scale my application and I have multi-tenant, but I want to have 3 or 4 instances so that it can scale, I can do that directly with Aspire. Azure's Container Apps is a really great tool for this, and for people who aren't maybe familiar with deploying onto container apps or even containers in general, the beauty is Microsoft's kind of abstracted all of these problems away for you. So inside of Visual Studio or VS Code, if you've got the, let's just close all of this. If you've got the Azure Developer CLI installed, Microsoft and Azure can deploy this entirely for you without you having to write anything or do anything. So by going into the CLI and writing AZD, Azure Developer CLI, up, it's then going to analyze my application. It's going to ask me to log in, isn't it? Brilliant. So It's going to get me to log in. I have to copy a code, go next, put the code in, log in, come back here. It's going to ask me what I want to do. It's going to ask me to give it a name and do a whole bunch of stuff like, yep, I have completed, thank you. Thankfully, I did this earlier, so we don't need to worry about it. But it essentially prompts you through the process. It scans over your project. It understands you've got an Aspire application here. You're going to want to deploy that to container apps, and it does it for you. It deploys some resource groups, and away we go. So if we look over to Azure here, where I have already done this earlier, I created a project called MCP demo. I've told it to create that in Azure using AZD up. And what it has done is created a container app server called MCP server with a bunch of other stuff there, container registry to deploy it to, some best practice security stuff like a managed identity. And if we go over here and refresh, you can see I have my MCP server running in the cloud now. And as many instances as, oh, it's failed to boot one of those. Okay, we can maybe restart that. But you could then do exactly what we just did locally. You can visualize all of your instances running, and you can visualize all the different requests that are being made to these instances. So, like, don't need to know the infrastructure. AZD up, once you've got a Aspire application, it's deployed in the cloud. But let's talk about how we would secure this still, because the problem still remains. This is public. So that's where the Azure AI Gateway or the API Management Service actually comes into play. They've got some fantastic tools in here for protecting resources like this running in the cloud. If we go to our API Gateway and we go to provision a new API, we can say that we would like to have our API backed by a container app. And through that, we can just select the container app that we've already got running that's been deployed for us by Azure. We can click Create. And this will give us a protected endpoint that we can... Oh, I already did it, didn't I? Brilliant. This will give us a protected endpoint that will have everything we need, best practice configured, and monitoring to make sure that no one's trying to use our APIs maliciously. I'm going to zoom out a tiny bit. Sorry for people at the back. You can see here it's mapped to our MCP server container app. There we go, running there. And we can then start to enforce certain policies to protect and control the app how we want, such as rate limiting, such as a thing called semantic caching, so that if we get lots of the same requests coming through, it will analyze, it understands the tokens that are actually being sent by the large language model, and it knows that, oh, you're within a sort of 90% similarity range, and therefore we consider this the same request, and we can just return a cached copy of the previous response rather than having to call off to the server in the background. A great way of offloading some of that traffic to the gateway. Let's look at what one of these policies looks like. They ship a whole bunch of default ones, but if you go to the other policies, we get this like XML-based configuration manager, and who doesn't love XML? Thankfully, I hate it, but we can go to the Copilot, and directly inside the Azure portal, it can tell us how to do everything we need to do. So earlier I asked it, how can I add rate limiting? And it gives you the snippet that you need to add. So in this case, inbound base, define the backend service, add my rate limit. That's 1,000 calls over every hour, basically. And then I also wanted to set up semantic caching, which does require a Redis cache or similar to be configured, but you can pop that in there too. So a semantic cache, say, cache all these things for an hour, and you can supply into here parameters like these need to be this similar or whatever. So you can really start to get some granular control over how your service is consumed without modifying your application. I think this is a really cool way of securing your MCP server in production. But what's more is they've got a bunch of preview features. If you're on the V2 version of API Gateway, they actually have the concept of MCP servers baked into the gateway. So let's say you've got an existing API, you don't have an MCP server at all, but you've got an open API spec for that API. You can come into here, you can create You can point an existing API that you've got configured. In my case, it's just the same one. You can map all of your different functions to it, and then you can say create, and it will build its own MCP server for you. You don't have to build one. You can ignore all the .NET stuff. Just create an API that you're used to. Or, if you do have one, like I do, you can expose your existing MCP server. You can give it the URL of my container app running in .NET Aspire, and it will handle all of those things for you. If you want to offload auth and authorization entirely to the gateway, you can do that too. So the API gateway has this concept of connecting like Azure Entra ID or other identity providers for the actual API's authentication. And you can have that passed through to your server or just terminated at the gateway if you wish to handle authorization as well. So you get a whole bunch of very powerful control just by using the API gateway. For the sake of transparency, Cloudflare also has an amazing an AI gateway product that you should totally check out and does most of the same things and is a bit cheaper as well. But if you're in Azure, this is a great option. Now, I mentioned Den earlier. Den Delmaski's got a fantastic blog about building stuff with MCP, and he's got another one about setting up your MCP server securely with API gateway as well on .NET. So go check that one out too. Don't worry, the QR code's coming again in a second. So let's do a quick summary. The recipe that we followed today to build a very basic MCP server in .NET was to install the Model Context Protocol SDK via NuGet. We've also installed the Semantic Kernel package because it gives a bunch of really nice wrappers around C# and makes it easy to create a very native feeling application, integrate an existing application. The MCP server itself supports OAuth 2.0, but 2.1-ish, not that it's really a thing. We can use .NET Aspire for deployment and for tracing of that application. And it's a really good way of visualizing and managing your containerized instances, especially if you don't have experience of running containerized workloads in the cloud. You can use the AI gateway or the API management service for securing and production readiness, things like rate limiting, security, and auth. And then my final big one is this tip that I gave you earlier. Tool poisoning is a real big risk to you consuming MCP servers. So the best things you can do is, as an implementer, give it the best description you possibly can, and as a user, only take what you trust. Only accept the tools that you actually want to use. Don't just blindly accept everything that your client throws at you. There's those QR codes again. So this is a great QR code for Microsoft Learn as well, with some getting started examples of how to get up and running on .NET and MCP. Go check that one out. And then there's both of Den's articles as well here too. So you can read those and yeah, have a play yourselves. And with that, that's me. I'm on GitHub, and all of the samples I've showed you today are on that GitHub profile and are up right now. It's a public repo called .NET MCP. You can go and check that out, have a play yourself. I'm still on Twitter, unfortunately, and also Blue Sky and LinkedIn at that same handle. I'll be around for the rest of the conference. I'd love to chat. If you've got your own experiences of implementing MCP, I'd love to hear it. Thank you so much. Enjoy your lunch and enjoy the conference.